Good afternoon, ladies and gentlemen. Let's continue our lesson on independent sample t-test. So this is lesson 9.2b. As you are well aware that there's some steps here in order to compute the outputs for the independent sample t-test. Okay, there are some steps here, and we did that already. Now I want to run another t-test, independent sample t-test, in order to answer the research question. So I have the data here. This is the ID of the participants. Okay, and, from number 1 to number 56, and we have two groups. Okay, gender, I coded 1 for females and 0 for males, and this is the dependent variable that we want to compare the two groups on. So our research question is, do males and females students perform differently on research methodology semester 1 subject. Okay, this is the semester 1 result. We want to check whether male students perform better or the opposite. So in order to get the output, it's very simple. We go to analyze, we go to compare means, we go to independent samples t-test, and we can move gender to the grouping variables, and the dependent variable to a test variable box. And we click on gender in order to activate define groups. We click on define groups. Now we can enter 0 for the first group and 1 for the second group. We click continue, and we click on OK. So this is the Spss output that we just performed. So there are two tables, the descriptive statistic table and the t-test table. So I shall switch to our screen, the PowerPoint screen, because it's bigger, it's clearer over there. So you can see here in this table, you can see the two groups, male group and female group, and there are 22 males in this research, and there are 33 females in this research. You can see there are two means, the mean score for male students and the mean score for female student. It seems that female students score or perform better than male students. So they, on average, they perform around 4 points higher than male student, and we get excited. We might say, female students are better students, or female students significantly, scored higher than their male counterpart by looking at the mean. But that's not fair. That's not correct, because the difference between the two means here of around 4 points might happen by chance. We have no scientific evidence to conclude right now, right here, that the performance between the two groups is scientifically or statistically significant. So to do so, we need to go to the second table. The second table gives us two kinds of tests. And this column, okay, the third column, the second column and the third column is the F test, or the Levine test. What is a Levine test? A Levine test is a kind of test that assesses whether the variance for male group and the variance for female group are equal or are significantly different. So I think everyone still remember the first assumption of independent sample t-test. The first assumption is that the variances of both groups have to be equal in the population. So how do we read Levine test numbers or outputs here? It's very easy to read, to understand, or to interpret. We go to sig or significance or p-value. You can see p-value is 0.497. In other words, p-value is bigger or greater than 5% or 0.05. So when p-value for the Levine test is greater than 5%, we say that we conclude that variances of the two groups are assumed to be equal. In other words, variances of the two groups are not statistically different. Okay, they are not different. So in this situation, we support. Okay, we have these data to support the first assumption. The first assumption say that variances of the two groups have to be equal in order to use independent sample t-test with confidence. Yeah, we meet the first assumption in this context. In other words, I want to emphasize, in case you want me to emphasize this on how to read Levine test results. So we look at the magic number. I call it the magic number. This p-value. When the p-value of the F test or the Levine test is not significant, we say that variances of both group A and group B are equal. If, however, the p-value is less than 5% or less than 0.05, we conclude that variances of the two groups are not equal, are different. So that comes to the next step. The next step is to decide on the t-value, degree of freedom, and p-value for the t-test. So since significant, since the both group variances are not different, we are going to use the data in the first row. Okay, here the t is minus 1.992, degree of freedom 53. So degree of freedom for t-test is very simple. The total sample size, okay, 55 minus 2. So you're gonna see the degree of freedom, and the p-value is 0.052. Please take a look at this magic number again. The the p-value have to be less than 5% in order to allow us to reject the null hypothesis in our research. And can you tell what is the null hypothesis in this research? Yes, the null hypothesis is boys and girls do not score differently on research methodology subject semester 1 result, okay? Or boys and girls do not perform differently on semester 1 for research methodology subject. So since p-value for the t-test is greater than 5%, a little bit larger than 5%, so we conclude that female students do not score higher, did not perform better than their male counterpart, simply because around 3 points different out of 100 total score happen by chance. This different, just happen by chance. If you go to the mean score here, you can see males score 3.74 points lower. If males score like 5 points lower, we expect that p-value is smaller. Okay, is small, is less than 5%. Therefore, females significantly perform better or perform better than male student. Therefore, we go to the last number here. It's 95% confidence interval of the difference. You can see 95% confidence interval of the difference means that if we conduct research 100 times, 95 times out of 100 times, we will find that the difference between the means of males population and female population, the different range from minus 7.51 points to 0.03 points. If we conduct research 100 times, it just means that way. Okay, 95% confidence interval is another important statistic for this inferential statistic. In the next video, I will come back in order to explain all of these numbers again, in order to, reinforce our conceptual understanding of these numbers. I will make another video on how to read Levine test for equality of variances, and also the 95% confidence interval of the difference. So that is it. That is the end of this video 9.2b. Thank you very much.